because these systems, these LLMs, do not have an intent, it's not that we understand them better if they have a little bit of stochasticity. This is the way they hack into our attribution system to believe that they had something to tell us. And then, just an example, relevance theory suggests that once our attention is not lost, we bring in all our knowledge of the world.
Yeah, I agree. We project the intent into the text.
But also the meaning, not just the intent.
For me, they are pretty much equivalent. But what's the difference? What do you mean by meaning and intent? Like the meaning is what when you talk to me, the meaning is what I think you want to say, or
yes,
you want.
But I always have a moving target.
Yeah,
with the intent,
of course.
But not with the word meaning. Word meaning is relatively constrained.
Okay.
I actually have a paper where I argue that that's also based on attributions of mental content to the speaker. So even word meaning is determined based on mentalization, the intention of communicating some specific mental content, but intention has multiple meanings. One is this very distal one, generally, what do you want? Somewhere in between levels, there's this communicative intent. What's the gist you want to tell me? And then there's this very local intent. What do you intend to mean by that particular word?
Hi everyone, my name is Balázs Kegel, and this is the iScientist podcast, where we explore artificial intelligence, the body and the soul. And today it's my great pleasure to host my friend Bálint Forgács, who is a cognitive scientist from the ELTE University in Budapest. We met about 10 years ago, I think, when you were a postdoc in Paris, and I was directing the Center for Data Science in the Parisian University. And a lot of time went by. I followed your career, and I ended up contacting you because I changed job 2 months ago. I am leading a team at Meta Fair on developmental AI. Basically, want to figure out the inductive biases that babies have so they can learn way more efficiently than today's AI. In terms of language, it's orders of magnitude faster. And we want to learn from this and see how this can be applied in AI. And Bálint is a member of a BabyLab in the university. And one of the common projects that we may have is to see if we can collect data on how babies themselves learn and then try out models on this data. And so this is the apropos of our meeting. And so we got together 2 months ago and started to talk, but then we had really great like dinner conversations about cognitive science in general and AI, and even beyond, like consciousness, and exchanging on our experience in spirituality. So it went really great, and I thought it would be a great idea to actually record some of this conversation. Of course, a little bit more structured. There might be even more than a single conversation because there are so many topics. We will see, but this is essentially the first one in this series. So hello, Bálint, and please introduce yourself to the audience.
Yeah, thank you very much for inviting me to continue these conversations that we had that were really exciting. I'm a teacher and researcher at ELTE University, and currently I'm also a postdoc at the Freie Universität Berlin. So I have two main topics in cognitive science. Both of them, it could be relevant and related to AI and language and cognition in its philosophical terms and problems. One is metaphor, how the brain processes figurative meaning, which is a non-trivial procedure, especially its rapidness and its fluidity in everyday conversations, because figurative meaning is somehow uh, an additional layer. I wouldn't say a second layer or secondary layer, because very often it's a primary, but the trick with it is that the brain somehow computes a meaning beyond the literal. And so it assumes that there's a literal as well. And then it's still very rapid and at ease coming up with a meaning, and we don't even, that is figurative, which we don't even recognize even very often or know that it is figurative. Now, the other area of mine, and I'm doing EEG experiment and fMRI experiments, and in Berlin now we're moving from the expressions themselves to their visualizations, visual metaphors. And the other thread I started as my first postdoc at the Central European University is infant research. So there I started at the CU's BabyLab, and then I went to Paris, where we met, to the LPP, and then Université de Descartes, Université de Paris today, and it was Judith Gervain who was my supervisor there. And then I moved back to Budapest to the BabyLab of Ildikó Király, and I'm doing the EEG experiments in the BabyLab. And I'm still investigating language, so it's how language is acquired, but not from the linguist structuralist riddle perspective, which is very often investigated with statistical contrasting with statistical learning, or sort of figuring out predictable patterns in language, but from the perspective of social cognition. So the traditional science, financing, and bracketing structure, this is a rather different disciplinary approach, because this is from the other end of the aisle. It's from humanities, from social. But this is a widespread and hot topic in baby labs, because social cognition became tractable mostly because these baby labs allow for sophisticated technologies to be used for data gathering, but also the innovative experimental paradigms and the innovative theoretical frameworks like that of Tomasello or Gergely and Csibra, who proposed models of how learning is beyond imitation, as in our closest ancestors, and how high-level learning is possible or could be possible, and they provided frameworks for that. A little bit an analogy to but further specifying to the Chomskyan idea that there must be some innate learning mechanisms, rules that are uncovered instead of developed in development, during development. And this is also generalized to social cognition. So what are the basic settings that enable infants to navigate and actually to use this navigation to learn from social partners? And then this intersection I'm working on, the social N400, so semantic processing in interactive situations.
Beautiful. I mean, it really leads to the first big topic that we were talking about, and I want to cover here, which is how do babies discover or invent structure? Then I'm doing this on purpose because that's going to be one of the questions. Exactly what you described. What is built in the cognitive scaffolding of the baby before they are facing linguistic input, and what do they learn? Because I remember even from the 90s where I was attending the same cognitive science lab that you grew out from in Budapest, and the big symbolicist connectionist debate was like raging in cognitive science. And it seems like because of this huge success of AI, connectionism won. And in a certain sense, it did, because in AI, at least, the pure structure-based, language-based approaches didn't work, didn't scale. We couldn't adapt them to real text and language, whereas the connectionist approach took over, and all what you see in ChatGPT and other AI engines, that's the winning paradigm. And the underlying assumption there is it's a very weak inductive bias, which is that from a huge sequence of words that were written by human, we can learn how to generate new words. And by generating new words, we solve intelligence. So there are two related sort of hypotheses that seem to be validated by AI. Yet, the research I'm involved in now points out that babies take 2 or 3 orders of magnitude less data to learn a language than what we use to train foundation models. And even from a technological point of view, figuring out what those inductive biases that make it possible for babies to do this, it would be great to understand this, because in that case we could have models that are much more adaptable to local conditions, like a personal, somebody's own AI, which is like a red hot domain today in AI, because this is actually where the limits are, right? We don't know how to use this huge foundation model that's generic, that like have all the knowledge of humanity, yet it's somehow an average of everybody that were included in generating those texts. So the question I want to ask is like, what do we know about how babies learn language, and how is it different from this purely connectionist paradigm that we are using in AI?
Yeah, these arguments are that Chomsky came up with are really sticky. So it's difficult to get rid of them. It's easy to dismiss them, but it's very difficult to get rid of them. And it's really this magnitude problem, which is also going to be a key problem for this personalized AI, in the sense that it's going to be a very limited amount of stuff and data that people can feed into these models. That's their own making. And it's going to be ever more limited as time progresses, because everybody uses, or so many people start to adopt AI, and then it's just secondary AI generated. It's just the prompt that's original. But for infants, yeah, I was calculating silently, maybe actually 4 or 5 magnitudes less. So if we think that it's about 10,000 words that a 10-year-old knows, and it's I don't know what the size of the internet is, but it could be hundreds of millions of tokens, could be even a billion. Then it's like 4 or 5 magnitudes less. And so to me, this question is, we know what we don't know. We don't know actually how this happens, but so I have some theoretical commitments that I'm not firmly attached to, but I'm just going to flesh the story out that I think it's possible to do, because it has been shown pretty early on that statistical learning plays a very important role, for example, in differentiating and learning the phoneme structure of a particular language. From the possible set of 120, 150, maybe it narrows down to a specific language phoneme structure. And that could be actually the closest in my mind, to the original Chomskyan proposal of parameters and settings, because that's very well defined, a problem space. What happens beyond needs also some innate structures, I believe, because word learning is so incredibly fast. So you don't need to do reinforcement, backpropagation, or whatever kind of teaching strategy. It's a really strangely quick 1, 2, 3 exposures suffice for words. So what happens there is that you need to, it seems that babies are equipped with, once they are through an initial setting of this, some key parameters like the phoneme structure and perhaps some basic grammatical structures based on language statistics. This is the works of Judith Gerva, in that you have content words and grammatical function words appearing in natural language at different frequencies. And then if your language is like Hungarian, for example, puts all the grammatical markers at the end of words as suffixes, then you learn from the statistical properties of syllabus and acoustics of the language that the first part of the units is usually a content word, and the second part is the functor. And it's just the other way around in English, German, or French, except for the few grammatical conjugation that those languages do, but that's not comparable to Turkish or Hungarian or languages that do most grammatical stuff at the end of the words. But so after this stage, there's a lot more happening in the social domain, and it's the way it's happening in the social domain is that it's statistical regularities are not that important. You still need regularities, but it's not statistical in the sense that you don't need big data. So one model is the natural pedagogy model of Gerge and Csibra, which suggests that with certain so-called ostensive communicative cues, eye contact, eye gaze, so personal interaction communicative cues, contingent reactivity, which is like this Q&A structure in conversations, but even in breastfeeding, this is the turn-taking switching that needs to be within a time window. The response needs to be within a time window to the question. Otherwise, you don't consider it as a response. And so this back and forth is a timed rhythm of the interaction, which babies are sensitive to, likely in some sense. I've been working this on at the CEU, and we didn't find clear evidence how the contingency structures are extracted. But this is another communicative cue, perhaps, and motherese, infant-directed speech. So and this boils down to being addressed to some extent. So when an infant feels or detects, so these are cues, so it's possible to make an information model out of it, that they are addressed by a trustworthy person, and this trustworthiness comes back in the works of Ildikó Király and Kata Ola at Budapest, infant ELTE BabyLab, which is the natural sociology. Who do you consider to be a trustworthy teacher? But let's assume it's your parent, and you already have the trust established, and you receive these ostensive cognitive cues, then a different kind of attention or learning mechanism kicks in, where you immediately generalize. So you don't wait for the data to come in from which you extract some kind of pattern that you generalize, but you take sort of a top-down approach. What I receive in the next window is the model itself. Now, for this, you need to have a template to fit it into.
Can you explain this? What do you mean by this is the model?
This is the generic thing. This is the normative thing. This is what is shared by everyone. This is the template in some way. So when you learn the name of an object, that it's a car, you don't need to see a lot of cars. You don't need to see, you don't need to hear a lot of object labeling events that are unambiguous. You do collect some statistics there, so probably you need to see a few cars, but you don't need to see that many cars. But this goes into the problem of concepts and categories. How do you build them? Let's leave that to the side now, but you don't have a lot of experience with all the categories for which you get the labels. So this is also, in my mind, needs to be somehow governed by a generative model that generalizes too soon, as opposed to building up the data or building up the contingency structure, if you will, or the statistical structure of the world. And then when you hear that the label car, then you immediately make the assumption, and there are various alternatives within this theory as well. What is the actual assumption that you make? But you make the assumption that it's the first version was that it's normative, that it's shared by everyone in the community. So there's generic knowledge, and they actually showed it with actions, tool use, how to turn a light on. This was the famous head touch paradigm. So if babies were addressed ostensibly before an adult, demonstratively turned a light on in front of them on a table with their forehead, there was a lot more head action when the object was offered to the kids than hand action. There was still a lot of hand action, but there was a lot of head action. So the interpretation was that this is normative shared knowledge that I was passed on by an elder, an experienced person of this culture that we share with. This is how we do things here. And this generalizes to word learning. This is how we call these kinds of objects that look like a car.
So let me interrupt you there, because I need to understand, because this is about, okay, I can understand naming a category is pretty fast, but how do we actually generalize what that category is? Because a car, I mean, perceptually, if you go down a detail level, it's never the same, right? So it requires something already there, which is sort of like a categorization engine. That it brings me back to phonemes, which is maybe where it happens the first time. So there is a certain hierarchy that is built up even in language, which is, I mean, it's trivial if we look at even written language, because we have words and phrases and sentences and paragraphs and chapters and books, etc., which is not really used in AI. It's discovered by the transformer, by attention, but it's not an inductive bias that we are actually using today, that there is this hierarchical structure. And what's interesting for me, because this is what we are working on, is how it's built up below the word level. And this is what babies do, because they don't read, obviously. So they learn this from audio signal, which is a continuous flow of, sound. And somehow, at the very low level, they discover these phonemes. And the big question for me, what is built in for discovering phonemes fast?
Yeah.
And then we can go and talk a little bit about how the hierarchy of categories build up, because this is what we need then to name rapidly a car. This is what I think about this. So, but let's talk about like how what could be the inductive biases that allow the baby to hear phonemes fast.
Yeah. So there are far greater experts on this part, and a lot of the colleagues at the LPP in Paris were working, like Thierry Nazi, were working on these sorts of questions of the consonant vowel distinction and biases and periods of developmental periods where one is preferred over the other. So there are lots of cognitive mechanisms that may be relevant from an engineering perspective as well, but it's not clear cut. So there's no, as far as I know, there's no clear, as of yet, description of what is actually the system is doing. But we have good, very valuable data insights into some parts of the mechanisms that are putting out this machinery. The question of categories itself is a huge challenging problem, because for one part, and maybe because I'm biased because I'm working with language, the way scientists use concepts and notions, that's also sort of well, at least nudging their perspective. And very often they use words that in different senses, and then very often they use different words to mean very similar things. So that creates a kind of confusion of the things themselves. What are the things? What is the category? What is it, a classification? I think there's a graded continuity between classification, categories, and concepts. And we are having very exciting discussions with my students, and I'm teaching a course on this, and they have really excellent insights. But it's very difficult to get one's head around what is the thing that we call categories so casually. Now,
Okay, so let's make an attempt. For me, it's just a group of things that belong together for a reason that is valuable for us. I mean, creating that category is valuable for us, and then we just put almost arbitrary things in it, which we can then also, of course, perceptually justify, perhaps perceptually sort of cluster, but it's very, very fuzzy, like how this created. I don't think it's purely like there's this big debate, like in AI, most people, if you ask them, they will say that this can be learned from data. Just, record the universe with a video camera, and then objects will just emerge.
yeah,
And
it would have happened already. If it was like that, it would have happened already, long ago. And so my assumption
it's not
is,
so clear because the engineering tricks that go in have a lot of insight from what we do, because most of the time when we do that kind of job, we have labels for the data, and those labels are exactly, we're doing the job, right? It's telling to the AI what belongs together or what's not. Is it a dog, is it a cat, or is it the type of a dog? So it's also hierarchical, of course. But there are people working on the hypothesis that this can be induced just from video. And you are right, that those approaches don't work yet, or maybe never, but the assumption is definitely there. And what I think is there is a top-down thing in it, like the agent that actually is watching the video has a say about what is an object and what is not, what is a category, what is not, even though, of course, there are perceptual features that must be there, otherwise we couldn't do the categorization. But on top of it, we also need some kind of top-down thing, and it's sort of coming from the fact that we are an agent with goals, and for those goals, those categories are valuable to create. This is how I see it, and this, like John Vervaeke calls it, transjective. So it's neither in the data nor just a pure projection from the mind, but somewhere in the interaction. So what I'm looking at why I'm bringing the phonemes up, because this seems to be perhaps the lowest level transition between the continuous audio signal and something that's chunked.
Yeah.
Right? And we know that there are statistical properties that can have the chunking. And maybe at that level, there's a lot of bottom-up things for the baby. But what I would be curious, because this is what we are looking for as inductive bias, what are the weak, maybe even weak assumptions that we could inject into the system to make that learning faster?
Yeah, well, this becomes an engineering problem. And even if we have an engineering solution, it won't prove that that's how nature did it. So, but for the purposes of the engineer, it doesn't matter that much, except if there's something to take from nature. And I would go back later on to your definition of categories, as value to me it's a problematic foundation because it's so volatile and it could change from situation to situation. But coming back to or staying with the phonemes, we don't even know how much is that a lot, or actually we don't have a quantification. We don't have a number on how much input the system needs, even for phonemes. We know the time frame for the narrowing, but perceptual narrowing, it starts around 6-7 months, and then it's lasts until 9-10 months. So that's the time period when kids start to be specific to their mother tongue's acoustics. But there are cultures where people don't talk that much to babies, and maybe babies don't even overhear a lot of other people because they grow up in communities where there's not a lot of other people. So it could be relatively a lot, but it's still a question how much, and what's the statistical extraction tool there. But what seems to me something that the system is very well suited to pick it up, and for it to be very well suited, it specializes in human speech. But human speech is also a product of evolution. So it's actually a co-evolution of the production system and the listening system. So that makes it even more tricky in some sense, because perhaps we produce sounds that certain ancient acoustic systems were able to pick up, but then those acoustic systems further specialized to those particular sounds, which were then further streamlined. So it's not the thing that there's a system in our brain that just picks up stuff. It's a very dedicated, specialized organ, the ear, which has its very dedicated, specialized low-level feature processing devices, which are totally generic, and it's probably unchanged for maybe hundreds of millions of years. And then there's some added structures that are able to differentiate human speech from non-speech, and this we know that newborns do. And chimps don't do adult or baby chimps.
And so do newborns do it from the beginning, or they need learning there?
They don't need learning there. The human speech and its prosodic patterns. So they differentiate. There were lots of experiments on this, and one of the leading figures in this was actually the former PhD supervisor of Thierry Nazi and Judith Germain and a bunch of people at the CEU, the famous French cognitive scientist Jacques Miller, who initiated many of these newborn studies on language and contrasts with reverse speech and forward speech and music and speech. And there's quite a lot of data on that, given that it's, especially considering how difficult to test newborns. And so that's already a huge feat because in these experiments in the 60s, 70s, when people took in their homes non-human apes and taught them sign languages and lexigram boards and whatever, in an attempt to show that it's the cognitive apparatus is there. It's not just the lack of the acoustic production system. They still didn't pick it up. And when it's about sign language or lexigrams, it's still hundreds of pairings. So they are actually doing statistical learning. So we have a very good contrast how it looks like when it's still a specialized system in some sense, because it's able to create contingencies between object classes and so visual classes and acoustic classes or other visual classes. So if you associate a symbol to a phenomenon, to an object, you describe an apple with a triangle or whatever, or gestures, or you can even learn to understand some human language, human speech, but they don't pick it up unless there's a banana involved in the situation. So if there's no reward,
there's the value.
Yeah, exactly. So you can. It's just the concept of the value is just so.
I know. Anyway, we'll get there.
Volatile. We'll get there. Yeah. But so the point I want to make is that first you have this capacity to differentiate speech from other, perhaps even similar environmental noise, other vocalizations. So it's a third class, and I've heard a talk, a very interesting talk that analyzed it as being somewhere halfway between natural noises and vocalizations. Natural noises in the environment are more similar to consonants in their acoustic pattern,
yes,
and animal vocalizations are more similar to vowels. And so we have these two integrated. So it's somewhere in between, and that's what creates a special stimulus class that the newborns already pick up. And then they start to do some structured analysis based on perhaps statistical contingencies, some entropy functions or whatever. So predictability. There are lots of artificial grammar and pseudo word experiments, also with newborns, also with 7-8-month-olds. So statistical learning was actually first investigated using language and structured syllables with certain transition probabilities between them. So these transitional probabilities could help them, but in these experiments it was not directly phoneme, it was mini-syllables, so like a consonant-vowel pair. So you have a constant stream. That's a huge challenge to do the segmentation between words. But first you have to solve the segmentation between these sound structures. And we can't exclude the possibility that there's a dedicated system to that. So this is what I want to say. So this is the point I wanted to make. So just because they pick it up from the raw data, even the first bootstrapping could be aided by some dedicated feature detection. And then this is not simply statistics, because it's statistics of detected features. And then the features could be already forming some forms of classes. So there may be a really early classification between consonants and vowels, or certain classes of sounds produced by different parts of the speech organ. And then the prime example of categorical perceptions, so that the perceptual system lands on something that is productively combinatorial, is again phonological differentiation between native and non-native sounds. So that's where categorical perception was first detected, but it could generalize to other kinds of categories.
Yeah, and that step tells a lot about what's going on, because there is where individual babies differentiate depending on what language they hear. So what we are looking for is what is common in those mechanisms that then can be specialized to a certain language, right?
Yeah, exactly.
Going even further, what I'm interested in is the actual urge to categorize. You see what I mean? Maybe there's a built-in urge to categorize. This, which is used everywhere, not only in picking up phonemes, but perhaps that's one of the earliest. But of course, it happens in the visual system too. That certain perceptually different things different, but maybe similar, but we're also discovering how they are similar by categorization. So when you have a top-down categorizer of two things that are very perceptually very different, somehow we still manage to connect them, right? So you have this bottom-up thing where you have some perceptual similarity, top-down thing, question mark, what it is exactly, that makes us create categories. And so where, today's AI is blind a little bit, that first of all, its input language is already highly categorized. It went through, at least 100,000 years of evolution of what we mean by a word. It has a history, but it also has a present, but we have a vocabulary, and those words are categories basically that put together, perceptual or abstract things. There is a hierarchy, of course, and everything, but what goes into the AI as an input, it's already categorized. So today's AI is blind to this problem of how this categorization happens in the first place. And it's also not using this same engine that we do above words, because we have concepts. We go into a space where we cannot really name something, but we can describe it with a paragraph. And that is fuzzier, but still, the way I imagine is that this is how categories are then created in history or in time. Certain concepts become so important that we name them, right? And so what I'm interested in is just catching maybe the first or the lowest possible least complex thing where this categorization kicks in, and trying to understand the basic principles of categorization, because we always go from continuous to discrete, and then in the discrete space, as you described very well in our conversation, then we can do a lot of beautiful things that are symbolic. Reasoning, math, language is somewhere between for me, but let's say pure math and logic are like purely in the symbolic space. So you know where I'm going. So this is why I'm interested in how this categorization. What do we know about what is built in about categorization?
Yeah, it's yet one of the $1 million questions, because as far as I know, it still could be just simply language. That's the problem here to some extent, because of this, because so probably animals do have some representations of objects, and they're able to track objects, and okay, non-human apes are really good in tracking objects and the physical world. But we don't know if they see the things that they perceive in similar ways that we do. And it could be not just an adult's mind who have mastered, or a big kid's mind who have mastered language that perceives stuff like that, but it could be that it somehow through the course of evolution trickled down to some cognitive structure that is there already at birth. Just as identifying human speech versus not human speech at birth is somehow an evolutionary adaptation that specializes in that context. So to rephrase the
So
problem
you mean it's not necessarily the inductive bias of categorization that's there, but the categories themselves, or some of them are already there.
Yeah, exactly. And then it's a lot more about the template matching, which could be rapid. And if it's false, erroneous, you can correct it really quickly, so it doesn't show up.
So there is some learning, but it's on top of like something that's already pretty well.
Yeah, but not defined in a way as the churchlands criticize Fodor. So Fodor has been criticized with his 50,000 innate concepts that it's ridiculous to propose that kids are born with airplanes. The proposal is not that, is the capacity to have 50,000 distinct, computationally compatible symbols.
Yeah, that's exactly what I'm saying. Like that's what I mean by urge to categorize. We have
Yes.
space holders that we can
Yes.
use, and we have a inclination to see similarities and put them into
Yeah.
the same category that have some that share. So what I think is that it's not only perceptual, but that's where I differ from most of my AI colleagues. That it's functional, it's affordances, and it depends on us a lot. It's not out there but otherwise, yeah, it's this is what I'm getting at. Whether so, what are the how could we formalize such a system that has this built-in urge to see discrete stuff in the continuous flow?
Yeah, well, you have to have a predefined structure. So this is where natural pedagogy theory has been moved towards by Csibra. Recently, he has been talking about the sensitivity of symbols, towards symbols, or having symbols. So it's not actually what happens in the natural pedagogy procedures. Of rapid learning is not that the information is taken to be normative, or later it was thought to be generic, but that a symbol is assigned to it. And then it happens to function in a generic and in social relations a normative way, but it has its bubble around it. It's discrete, and it can enter a combinatorial computations in a productive manner. So this would be very much similar to the idea of Fodor's language of thought, that there's a predefined computational system that Fodor had some weird ideas about some other problems that come with it, like suggested that learning is impossible. So it's just incidental and accidental, and it's just a matching procedure that is not systematic enough to be named learning, in my understanding.
Okay, that's pretty much yeah. So we don't want to go there, but we don't want to do the other extreme either, which is like very, very weak inductive bias.
Yes. So what happens there is that there's with these systems is that the statistical approach very firmly sticks to the prototype theory of Roche, which dates to the 70s. The first paper was in 69, I think, so it's 60s even, which is just the idea that categories are emerging based on encounters with members, which are then averaged together into a prototype. And seems so obvious that it's taken obvious by many, but there are serious problems with this theory and with the theory itself. So we are stuck currently, 50 years later, how categories work, because there are rival theories that can account for distant and distinct problems that are surrounding categories. And so once you think this is obvious, it's so easy to believe that you can go from features to symbols. But that's actually a huge problem. And that's why, for example, Gary Marcus in his 2001 book, In the Algebraic Mind, points out that if you, in your input layer for a connectionist network, have symbols or units that correspond to symbols, may correspond to symbols, let's say proper words, like nouns like cow, cat, horse, whatever, that's already an implementational connectionist network of a symbol grinder. Because the input layer is symbolic, you already start with the assumption that there are things in the world that we may label symbols, and then you just a little bit scared to use those symbols in computations, in algorithms,
it's more than that. It's not about fear, but about like or based on this intuition. There was a long history of AI that tried to build those symbolic systems based on logic and set theory and all kind of like this symbolic theories, right?
No,
and they didn't work. But the interesting thing was that they didn't work, and this is why the pendulum swung to the other end now, which is completely connectionist. Yeah, go ahead.
Yeah, sorry, I just wanted to say that if you're a connectionist, you may not want to use operations if you use symbols inside connectionist networks as input layer.
But it's ridiculous, right? In the sense like LLMs input is language, which is discrete symbols.
Yeah. So in that sense, it is an implementational network. The true connectionist, eliminativist connectionism is that you don't have neither symbols nor operations, logical operations, just features at the input layer, and then summation of activation in the network.
I don't see there the contradiction, by the way, because this is why I see this debate is a little bit academic, because I mean, we can interpret certain activation patterns as symbols because they mean something for the network and they repeat, and so that might be that like the brain is just these neurons, so it's sort of like a physical implementation of both connectionist and symbolic systems, and some of the systems are, and we get back to value there, is more useful to describe as a symbolic system, and some is more useful to describe as a more fuzzy connectionist system where learning can take place especially. And it seems to me that everything we do now in AI is a hybrid in that sense, right? And now we are building like reasoning machines on top of these I wouldn't say blind, but like very basic word predictors that seem to be doing what the mathematicians do. I mean, the jury is out whether it's useful or not, but there are examples where they discover symbolic things like theorems that weren't there before, or we didn't know about before. So it's I don't know where I want to go with this. It's just I never liked the debate because it's it's different views of the same thing.
Yeah, I agree with that, but I like debating because it can highlight the weak spots of one theory or the other. And I think this is one of the weak spots of current LLMs, if they pretend to be statistical machines and they are not including architectural. So they are really minimalist in their commitments, nativist commitments, yet they use a totally nativist starting point that the inputs are words.
Exactly.
But then they slice the words up in a way, the intermittent layers. So they slice the input not along words. So it's totally crazy. If you want to calculate word frequency using these systems, you have to do a lot of trickstery to get words back as units. So in some sense, these networks they
use the hierarchy that's there in language at two levels at least.
Yeah, but from a linguistic perspective, they smear or from a symbol processing perspective even, they smear the categories that were fed into them, and then they do something really interesting that we can't really productively peek into, but then they give really exciting outputs that fascinate people. But the problem here is very difficult to analyze what they are actually doing, and yet they take just this one thing from a symbol crunching architecture, that there exists something in the world we can call a symbol, and then nothing else should be there because it all should be statistics. Yet and it dismisses the structural analysis. So it was used; these LLMs were used to disprove Chomsky finally after 7 decades, that if an LLM can do a grammatical judgment of a sentence, then it's finally done what Chomsky said that it would be impossible for a machine. Well, maybe it's possible because the starting point of that machine was a symbolic unit. And so where I want to go with this is that it's very difficult to define in what sense a system may be hybrid, because if you look at it closely, all systems are hybrids all the time. Yet our brain is showing, and not just our brain, even bee brains are showing characteristics that are very difficult to account for unless you assume that they are doing computation. So the big debate here, in my view, is whether you're a computationalist or a statistician, in the sense that, which are two different things. So the probability theory, through in various ways and forms, has taken over large swaths of cognitive science. But we know that nature uses a lot of computational stuff. And just to go back to some route example, the DNA is not a statistical machine. It builds, really, it's a computational stuff. It builds proteins based on 3 base pairs. So it's the original architectural foundation of the brain is a very strict computational system, just as our computers today that are used to run these large neural networks models.
So that's actually an interesting thing that I will think about now, whether I should go there. Because I'm not sure if it's related to this argument or not, but when you say it's the DNA that builds the protein, it's not the DNA that builds the protein. The DNA is just sitting there.
It's the RNA.
So,
okay, simplify.
No, nothing. What I want to say is that is the cell. It's top down. The DNA is sitting there as a blueprint, as a toolkit for the cell to build the protein. And it's the cell who decides which one to build, right? So I don't know if it's relevant to this or not, but maybe, because this brings in the top-down thing.
I think it's relevant, but I'm not enough good in genetics and cellular biology. But from the old school DNA perspective, you can say that it's the cell from in one sense, but from the old school DNA perspective, it's just the DNA.
I know. I just don't think it holds. It doesn't.
Yeah, but I mean, certain parts that are open in the code are opening other parts and defining which third parts can be read out or not.
Or not. It's up in the air right now.
It's okay. It's up in the air, and it's definitely, there are some external influences, chemical reactions that are happening at the cell surface or inside the cell that are also influencing which genome parts are being read out.
Yeah.
But there's an anthropomorphization in saying that the cell decides. Because,
of course, I mean, I wouldn't call it anthropomorphization. It's an assumption that the cells have a will to do something with that tool that they have, which is the genome.
But at minimum, it's a possibility, but at minimum, it has to be interactive.
Of course, it's always interactive, yeah. Yeah, so
So
in the language terms, I don't know. Again, I'm just completely like riffing off of this, so I'm not sure if it's relevant to the symbolist connectionist thing. But in linguistic terms, this would mean that language is like, let's say that's the genome, but it's us who do something with it, to use it for something.
yeah, I haven't think about it this way, but it could be somehow translated as an analogy. I don't know how far the analogy goes, but there may be a DNA-like blueprint
Mhm.
that is doing pattern matching based on very little statistical input because the pattern matcher is already a dedicated system that picks up very specific things. So there are multiple evolutionary toolkits that are bound together. But I would assume that there is a blueprint for language to which a sort of nowadays sometimes this is called also in this is the analogy
Mhm. Mhm.
for social cognition, a generic model.
Mhm.
So you come with a generic model and then you fill it in
Mhm.
and you're looking for things that are inputs for you, and then you also place them in a predefined hierarchy. So for this, you need multiple tools to identify to figure out how it's related to other stuff, but you don't do it from scratch.
Mhm.
And then what language does is then, of course, the phonemes are somehow identified, use statistical binning of even very low-level elements, but which those low-level elements are coming from at the same time a limited problem space of the organ
Mhm.
producing them. So it can be maximum 150, no more.
Mhm.
Uh, but also, it doesn't really matter how you carve that problem space up.
In what sense?
It's categorical. So you can
Huh?
have an A and an E in one language and an O and an E in Hungarian in another language, which just fall in between each other. And
Mhm.
categorical, it's a continuous
Yeah,
thing,
yeah, 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 yeah,
but
yeah, yeah,
categorical
yeah.
perception helps you. So the predefinition is not the content, but the form, in some sense, the pattern. But words are
Mhm.
elusive here, these words, because it's not a predefined pattern. It's not a pattern matching per se that you just check the similarity. But somehow it's a craving, a
Yeah, yeah, no,
carving
no,
out
absolutely.
system.
And it has to, like, information theoretically, it has to work out, right? In the sense that, and actually it was really surprising that I found this, that two phonemes have to be in a given language, they have to be differentiable by the perceptive system, right? And also
Yeah,
by producing, of course, but that's another issue. Uh, and so if you have this like continuous space of sounds that we can
yeah,
produce, and you carve them up into phoneme, the more phonemes you have, the harder to differentiate them because they
yeah,
are closer to each other. It turns out that if you look at languages, the more phonemes they use, the longer the phonemes are. Because you
yeah,
need some time to statistically differentiate, especially two vowel, where basically the phoneme is just repeating the same sound
yeah,
for a
yeah,
while.
yeah,
And if they
yeah,
are close, you have to make them longer.
yeah.
And there is
But
this correlation actually.
absolutely. But it has to be added that there's a lot of intermittent, hidden, rapid social learning going on here as well. I saw
Uh-huh.
a paper. I'm sorry, at the conference, I saw it maybe 10 years ago, so I can't recall the author. It was a Hungarian researcher, woman working with phoneme acquisition, and she showed in these phoneme space graphs that moms produce a lot more distinct phonemes of close phonemes in the problem space in a way that they tease apart
Yes.
the space
That's
until this
amazing.
categorical perception clicks in. And then you can use the regular one because your categorization structure will pull the input either here and there. And then there's a lot of jokes when you misinterpret things that you hear. Okay, so lots of puns play on that, and lots of jokes and funny situations in life. When these things are really close in their phonological space and are interchangeable to some extent, and then it really happens as well. But yeah, so the thing that you mentioned is again showing not necessarily the properties of the perceptual feature space, but how the system is set up to deal with a particular domain, assuming a particular set of elements in it.
Yeah. So this is fascinating because this is the point where the continuous becomes discrete. I can go with you that of course the manifold of possible sounds is fixed because it's fixed by whatever we can do with our production system, but within that this categorization happens in some way that you just described, right? It's like things get pulled apart, and then there is a point where categories emerge. What is fascinating to me is how the categories then act back on the perceptual level. Like we can forget actually to hear the difference, right?
Yeah.
Like it's acoustically different, but we still hear the same phoneme, and we would swear it's the same sound, right?
Yeah.
Typically, like in English, you have a and a, and for my ear, even if I can produce because I learned what to do with my mouth, I don't hear the difference. And if I tell it to the native English speaker, they will just laugh, From then it's like two completely different things,
Yeah, exactly. I have this also, and in French, the san and san, and it's
Yes.
super difficult. And I can practice it as long as I want. It's just too late. Because this is a sensitive period in human development when you may have some additional learning capacities active, or you may not have some top-down influences that strong yet, or the two, or some other factor. But there's a lot of parallel learning going on. So maybe when you start to produce, then you learn from yourself also. Or we have a study with newborns where we show that they are sensitive to not only the statistical properties of pseudo words, whether they have a repetition structure or not, and if there's a repetition, they show greater brain activation in their Broca's region, which is associated with language in adults. So newborns, they haven't heard proper speech at all, and their particular part of the brain is activated by repetition, like fe gugu, ze pipi, and it's informationally lower than a totally random ze pigu, shabu ze. These are more information because 3 different is more than 2 different than the second one repeated. But what we showed that on top of it, if this is a male and a female voice taking turns, it's even more activation in the language area, in the frontotemporal regions. FNIRS is not that accurate with this was a study with Judith Gervain and Tibor Tausin and György Gergely. They are even more activating these regions near Broca if the 2 sounds, the female and the male voice, do not exactly repeat each other. So if they repeat each other exactly, there's no chance for information transmission. So it's probably not as a good form of communication than when they do a proper Q&A structure. Zepipi, shalulu. Fegaga, mifufu. And when you do this, it's the language center that activates, not the acoustic processor, which is more temporal, not temporal-frontal. And this was one of the arguments that we also used in our paper, that differentiating between repetition and non-repetition is an acoustic processor's task. If you want to be like totally bottom up, this newborn is a tabula rasa. But actually, there's greater language processor attention going on there. And so,
I mean, for me, it's an attention cue. Because
yes,
it would not happen like by chance, you know?
Yeah, but that's human attention. So you can call it attention, but it's not ape attention.
No, I mean, it's human attention,
Yeah, so that's why I'm also referring it to as a sort of language thing, because attention makes people, at least in my field, think about the tiny goggles that we use to view the world through, and everybody who has two eyes must have some level of attention to filter all the input. Otherwise, even the biggest brains would just blow up, let alone the tiny brains of the information overload. And so this is very specific to language. And why I brought this up here, it's a little tangential, but why it's relevant here, that they are detecting the social part of interactions to extract linguistic information. And the other study that shows that moms tease apart the acoustic properties so to enhance learning. So there's a lot going on in interactions that directly aid acoustically, directly aid statistically, directly aid on intention from another partner, the low-level features to be fed to the
system. So that's even like another top-down part thing in this, like from the teacher's part.
Exactly. And you may assume so this helps the assumption that the learner can be sort of blind. There's a system that is very specialized, but to relatively general things, like there are acoustic features, there's a thing like language, there are symbols, I will arrive at categories of some kind, but it's totally open-ended, and then what is fed is designed by evolution, designed by character.
So this is where I want to go, because I think if we crack this nut of how phonemes emerge and being discovered and invented, as you said, it will inform us about what's happening above. Because another like interesting feature of this system we are using to communicate language, but also other stuff, is that it's hierarchical. This categorization is not flat. Right? And whereas a zip file, which is really, information theoretically optimal short way to transfer information, would be just undigestible for cognitive agents. So what is this cognitive bias that makes us learn, create, innovate, and discover hierarchical systems in this world?
Okay, to me, there are two facets of this question. One is that, and this is the metaphor researcher talking from me, is that be very careful with your analogies. So a theory can be characterized as a metaphor.
Yes.
And every metaphor can be characterized as a theory. And sometimes people fell in love with their metaphors. And then everything is a nail because they found a hammer. And it's very difficult to get rid of one's theories, naive or scientific, through an investigative work. And so what often happens
that's just another example of how top-down is hard to change from bottom up. Yeah.
But here's the thing: if you have the idea that we may be informed by bottom-up processes about what's happening levels higher, may be true, maybe not. So there's a big danger there. It's a possibility that phonological processing can be used as an analogy to uncover regularities on higher levels, but maybe not. So, because for me, this is not just linguistic analysis, this is also statistical properties, differences between phonology, semantics, and syntax. So phonology is, to me, really the closest analogy for the language acquisition device, because it's a fixed problem space that is going to be carved up in a certain amount of units. And that's really clean with phonological processing. But when it comes to words, so semantic level, combinations of these, it's potentially infinite, is just potentially infinite, is the language, is the sentence level that is definitely infinite. But the word level is just growing. So a single person learns about 10,000 words by age 10, about 20,000 by age 20. And then if you read a lot, you may go to 30, 40, 50,000. And János Arany used 60,000 across all his produced text. And Shakespeare, I don't know, I'm not sure, 100,000, 120,000? Once I checked it, but I'm not sure now. So if you put this up, then you can put it in the corner that actually Shakespeare.
Ask ChatGPT.
Yes. But the current state of English language is the number of words is beyond 1 million. I remember the newspaper article that English has passed 1 million words. And it's growing.
Yeah.
So that's an inventory that is somehow related to things and ideas, but in a very different way than phonemes are to acoustic stuff. And they have, words have a different, they already have a little bit syntactic-like, actually syntactic, but not grammar-like combinatorial rules.
Words, like morphology.
Morphology is one. But there's another thing, compounding. Compounds can be accusative, genitive, dative. They have their own world. It's very limited a syntax compared to sentential syntax, but it's still a syntax, and it's absolutely just within the mental lexicon. Compound words are mental lexicon elements. There's a big debate whether they are stored as in their separate parts and they combine on the fly, or they are stored as units, and then there are experiments that are favoring this theory and others that favor the opposite theory. And then comes the third level, syntax, which totally blows things up with very few things, because the syntactic rules are numerically a lot less than the number of words.
Well, we are getting into more and more math in a certain sense. Like math is typically like you have very few rules that generate a whole symbolic system where which you can decide what's inside. Say it again. Go ahead.
Yeah, so just then there's another twist of pragmatics, which is then a not well mathematics.
Yeah. So language is not math, definitely. So it always keeps some kind of fuzziness at the borders and concept categorization, because otherwise, so this was the big lesson from like 70s, 80s AI, is that when you start making a rigid logical system on top of these categories, like expert systems, they break. You cannot maintain their consistency when new things come in. It's exponentially exploding, computational, you cannot keep up, and the whole thing is just becoming a mess to actually maintain it from an engineering point of view or use. So
Yeah.
it must, yet we have math. So math is like completely rule based and completely symbolic, and then there's the word which is completely messy, and between them we have this language which has to be both at the same time. And maybe this is where
Yes,
the
but
debate sits, because it's both at the same time, right? It's soft but hard at the same time.
yeah, but it doesn't follow for me that the softness comes from statistics, and that's what the current zeitgeist is. Or
So what would be the no, I like that. I'm not sure I agree or not, but what would be the alternative? Where
the
does
alternative would be, and this comes back to concepts, is a kind of leniency with the rules. So a super special ability, a superpower of dealing with exceptions. And I'm not. This is not a full-fledged theory here, but what the problem with concepts is that, and that's why the system may have failed for different reasons than people attributed to them. Those symbolic-based world knowledge and semantic language-based systems. Yes, they are rigid because computer languages are rigid. Human languages are not. And human cognition is maybe have some computational power, not a little, but it definitely has a huge amount of flexibility. And flexibility is an ability to go cross-domain, to don't get stuck with counterexamples, don't freeze on exceptions, and you don't need to have a lot of stuff for that, actually, computationally. So you can still build a computational system. It's just what you need is that you can, at all times, assign and attribute empty variables. So if you meet something unexpected, you can just say, okay, I don't know what it is. It is something. It is a thing.
It's a category. I don't know yet how to define it, but it seems interesting. Yeah, okay. So we could go two ways, but I want to get back to the value question sometimes. But
okay,
riffing on of this, so learning definitely seems like statistical. Like we are learning repetitive repetitive patterns somehow, right?
I would immediately come with a counterexample, but sorry for
no. I'm talking about machine learning.
Oh, okay.
Yeah? Not us. Like ChatGPT.
Yeah.
Petabytes of text and big machinery and a lot of GPUs, and it just discovers very sophisticated statistical structures to predict next word. Right?
Yeah.
What is surprising is that it remains probabilistic at the generative level. So you could imagine a statistical learning that learns the categories and the hard facts and the language, and it predicts the next word from the history, and it's one word, right? You classify what is the next word.
Yeah.
And it turns out that these machines, so intrinsically they must use probabilities because they are learning. So they have to have softness in the system while they are learning. Right?
Yeah.
So in the beginning, raw neural net, all the vocabulary word has like roughly the same probability as the next one. And then they start to get input. They start to skew the distribution of next words to a subset with some kind of probability on each, right?
Yeah.
But they never collapse to one.
Yeah.
And you could artificially do that. You can ask the language machine just to to predict the most probable next word, right?
Yeah.
And in a certain like statistical sense, that's optimal, right? Turns out, if you do that, you'll hate your ChatGPT. It's dull,
Yeah.
boring, repetitive. It doesn't do anything. And I'm really surprised that not many people actually look at this phenomenon with a surprise, because that's contradicting the statistical learning principle, right? There is something where we want to keep the entropy at generative level, and the answers that ChatGPT generates in this way, even before post-training, but even after post-training, this remains skewed. Skewed, but not to one. Look, entropy is less than one. I mean, so perplexity is more than one. Perplexity is basically how many words you expect at the next position. And it's, for humans, it can be measured in experiments. And it's between 10 and 20.
Yeah.
And it stays stably there. It's not less than 10 and not more than 20. But the issue, so my theory on why is it like this is because when we speak, it cannot be one. If it's one, then I cannot give you any information, right? You know. So your language model about what I am going to say has to be open. Otherwise, I couldn't choose what I want to say among the words that you expect. Then you couldn't get any information from me, right? See what I mean? If your language model predicted all my words, I couldn't tell you anything. You already know everything I want to say.
Yeah,
It has to be wider than that.
Yeah.
On the generative side, what happens is that I have maybe a statistical language model, like I'm speaking, and then at every moment I have a choice to make between 12 words. I'm making those choices because I want to say something, right? I have an intent to communicate to you, right? So this is intrinsic to the language. It's because it's used for communication between two agents who don't have all the information about the other. That's the goal of language, right? But it's baked into the statistics of language. And it turns out that these language models have to keep the entropy. Otherwise, they are obviously meaningless, what they do, right? And it's very weird because what they do, it's a random coin toss. Right? They don't have intention, right? So they have to somehow choose from these possible words, and they choose randomly, and that random choice works better than the most probable choice. So what I want to say is that we use probabilities there in generation that don't have a statistical meaning. It's not statistical. It's something else. Okay, so what I wanted to, this is how it's related to what you said, is that learning is statistical, yes, but at the end, the product is also probabilistic, but not statistical. It doesn't, it's...
Oh yeah, okay,
I
see.
mean,
It's an interesting point, but I have
it's
a
more
very
like a
different...
Bayesian probability, where it's not about frequencies, it's about choices.
Okay, I see your point. Maybe I have too psychology-centric of a worldview here. But so I think there's a far more higher factor that determines what we say, and it's an intent. And so it's I would doubt that. So because these systems, these LLMs, do not have an intent, it's not that we understand them better if they have a little bit of stochasticity. This is the way they hack into our attribution system to believe that they had something to tell us. And then, just an example, relevance theory suggests that once our attention is not lost, we bring in all our knowledge of the
Yeah,
world to
yeah, I
interpret.
agree. We project the intent into the
Yeah, but
text. Yeah.
also the meaning, not just the intent.
Uh, for me, they are pretty much equivalent. But what's the difference? What do you mean
Well,
by meaning and intent? Like the meaning is what you, when you talk to me, the meaning is what I think you want to say or you
yes,
want.
but I always
Hmm.
have a moving target
Yeah,
with the
of
intent,
course.
but not with the word meaning. Word meaning is relatively constrained.
Uh-huh. Okay. Okay.
I actually
Yeah,
have a
yeah.
paper where I argue that that's also based on attributions of mental content to the speaker. So even word meaning is determined based on mentalization,
Uh-huh.
uh, the intention of communicating some specific mental content, but intention has multiple meanings. One is this very distal one, generally, what do you want? Somewhere in between levels, there's this communicative intent. What's the gist you want to tell me? And then there's this very local intent. What do you intend to mean by that particular word? And these
Mhm.
higher level intentions are organizing the local interpretation. So what you attribute as a high level intention could be different from the local meaning because you're waiting out
Mhm.
more information so that you can get to that high level. And you may be able, if you have enough patience and working memory,
Yeah.
to
To,
postpone what the high level intention may be and just take input at its raw or minimal form without doing a lot of
yeah.
intentional attribution.
Yeah, yeah, yeah. I mean, creativity lives there. How long can you wait?
Yes, yes, yes.
Okay. Okay, okay. So where are we on the because we started to go in this direction from your non-statistical but fuzzy category. So
Yeah, 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 yeah.
what I meant to add to that is that the current language models are also non-statistical and fuzzy.
Yeah, yeah, yeah. But I just got a little derailed there because I'm not sure if they do anything beyond hacking in our system. So
Possible it's like an imitation, but it's a very good imitation
it
of
is,
that
it is,
system.
it
Yeah,
is, it
it
is a good
looks very,
imitation.
very natural, and it can get into our interpretation machine
Yeah,
and actually inspire us. So it's really, when I work with ChatGPT, it can be very creative, that process, because of this thing that it does,
yeah,
organizing my raw thought into something linguistic, which then re-inspires me to go into certain directions, not unlike what we are doing now.
yeah, 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 yeah. Okay. Well, I have a different experience with them, but everybody has their own experience. So my uh, experience may be also limited because I was trying to spot it for years uh, in student essays, and and I'm not saying that I'm good at it, but the obvious examples I can spot now,
Mhm.
and it's very often to me it's a paragraph that at the end I wouldn't be able to say the gist.
Yeah.
Uh, because
Ah,
on a
okay.
local basis, I'm always able to attribute where this is going, but in the end, very often there's no development in where it is going.
Yeah.
And the
So
human,
yeah. I mean, this is. I mean, language models started like more than 20 years ago, or even 30, with that n-grams, and they
yeah,
were typically ridiculous above like three words. Like they had these two-word statistics, so they were like
yeah,
the three words made sense together, but then the fourth word didn't make it. So then as the mechanisms, the neural network mechanisms grew in terms of being able to digest context. This point where you could detect that it goes nowhere went further and further.
Yeah.
And right now, like in the new Claude model, you have like 1,000,000 word context that it can take.
Yeah.
So you need to wait a lot to see that it goes nowhere. And maybe that doesn't matter because I will go somewhere with its output, you know. So I can very well imagine if a student doesn't really know what he or she wants to say in the essay, then yeah, it goes nowhere. But it's sort of like you can actually grade it because it's a bad prompting. It's something that wasn't clear where you started to do the process with the AI. At the same time, if it's clear and you work with the AI because you can detect it too, that it didn't go anywhere, it doesn't go where I wanted it to go, or it didn't discover anything new, or whatever it was your intention to write the text, and you can refine it. And the end product, it can be pretty good.
Yeah.
But it's
Yeah,
not
I know
pure
that
AI.
people can
Yeah.
use it really productively.
Mhm.
My problem is that when they not, it wasn't the maybe it was ChatGPT 2 or GPT
Yeah.
when they
So
started, but maybe even 4, definitely all of them are exposed to now to these SAT tests and other these.
yeah, I mean the tests are also limited because we have limited attention. I mean, you will forget where you started. Like,
But it's a different way if you have knowledge. So what I wanted to say with that is that with the SATs, they got a grade on the difficult tasks like a C.
mhm.
So my problem is usually not the bright students, but those who are either just want to pass, they're bright that they don't care.
I see. Okay. So they don't even check it and just okay.
Yeah,
Mm.
and it doesn't matter for them that it's incompetence. So the thing is that, and there are students who are really incompetent, but they are not necessarily dumb. So again, that's also a C, but I can say something, what to do, where to go,
Mhm.
and how to develop yourself. And with the AI texts, I very often had this impression that I use it also, so I don't want to sound like a hypocrite. For some tasks, I find it really useful and helpful, but I think it's generating and is brewing a serious problem in science because people start to use it to ask questions, to structure texts, to structure problems. And this is very good if you know what the end result is. So if you're in a corporate setting and you want to know what the end result is, you want to make money. Or if you're in an applied research facility, you know what you want to do. You want to make a better car. You know what it should look like. Is the
Open-ended.
road there that you need to explore? So in clear problem spaces, I see it's more useful. But science
Exactly.
should not be, and that's my science philosophy, because the current way science is done is very much mimicking corporations and applied science, even basic research. And I think it's a totally misunderstanding what's value. Just to go back to the, not only to go back to the words you mentioned, but what's the actual product and how to measure the output, the quality of the output.
No, I'm
It's
completely with
just,
you on that. Yeah. I mean, this, yeah.
and in that, I see that these prompters, these LLMs, are very schematic. They chisel down the parts that make me excited from papers, from findings, the details, because the overview, the average, the bird's eye perspective, It's just, yeah, another study in memory. Super. Another light bulb lit up in some fMRI study over division of Earth from area.
But it's maybe the paper's problem, not the summaries.
But without reading the paper, you will never figure it out. So, because even if the important details are there, they are statistically insignificant compared to the overall net of the word cloud that was stretched by the entirety of the text that went into that paper. So there are lots of, and very often what I did in my research projects is that I found a very tiny niche that people forgot to control for, and there were 10 papers or 15 out in the reaction time of measured by reading novel metaphors. But nobody included a novel literal control condition. There was a literal control condition, but it was not controlled for novelty. It wasn't matched. So those are my first papers, replicating novel metaphor, conventional metaphor, literal. The triad was extended with a fourth one, differentiating the literal control condition into conventional literal high-frequency expressions and novel literal zero-frequency expressions. And this...
You can't imagine that this could have been found by an AI, this whole...
I'm not sure.
It sounds very structuralist, so they excel there.
Okay, well, unfortunately, it would be very difficult to do this experiment because then you would need to train the AI on the World Wide Web of 2008.
Yeah.
That's when I did my inquiry into the literature. The point I want to make is that if you feed in all the papers that existed before and all the reviews, all the big shots who were publishing by the ton, even back then, the textbooks, the anthologies of Academy of Sciences, all the received knowledge and its externalities, how they are supported, anything that disproved it was a statistical error in the first place. And I added something that was nowhere in sight in the corpus. Conceptually, it's logical, but all they have is the corpus. So, yeah, this is where I wanted to go here, is that statistical part and which if it's fully statistical, it's boring. So there's something that is not statistical, that is stochastic, that is in some sense gives a chance, and maybe this chance, maybe itself the ultimate power of the universe, besides the force of the Jedis, and this chance is in some level more systematic, but that would going into a religious and spiritual dimension. But even if it's just by chance, and that gives us somehow a spice, an information extension or unpredictability, that's why we like it. It still wouldn't make it more meaningful, because meaning is searched for in a different way. So our meaning detector has used to be paired with a meaning producer, and my suspicion is that these systems without intention, they are proxy meaning generators of those who train them, not necessarily on intention. It could be a lot of unintentional tinkering just to make it work. But those are not actual intentions that are related to the content that they sprout out. Those are engineering intentions, business intentions, and product intentions that then generate something that tickles that meaning searcher. And even if it doesn't find meaning because of justification, waiting for more input, relevance seeking, it will come to a conclusion that, wow, it's meaningful. And this is where Sperber genius guru effect paper also comes into. The new guru is the LLM. He mocks the Paris intelligentsia of certain not named philosophers who gather with their students in particular not named cafes, and then they seize, but the students keep gathering in those cafes, and because they wrote in such a complex manner, even if they didn't have much to say, so it's not possible to unpack any truly meaningful content, the effort put into the interpretation is so big that you get out some meaning of it.
So it compares LLMs to this? Like
no, it's my comparison.
It
compares certain philosophers,
psychoanalysts. I mean, meaning, there is no, like, there's no grounding or meaning in what the LLM puts out. We are doing that, right? But it can tickle that, and it can go in unpredicted directions.
Yeah. And so Sperber's argument is that they become gurus even without having much to say, because the students are then debating what the master could have meant.
True.
And he calls this the guru effect.
True. I mean, on the surface, it's very different, because that guru that you're describing is playing with complexity, like meaningless complexity, that we project meaning into it. Whereas LLMs, I find, they never do that. If anything, they simplify, right?
But maybe
their strength is the structuring information. And maybe that's
because again, it's not a hierarchical structuring, it's a statistical frequency-based structuring.
So, yeah. That's true, but still, because of the huge context length and the huge corpus.
Yeah. So there are features of there that can be brought up in their defense, and they are clearly not totally out of the horizons of what people think meaningful. So there are positive characteristics. There are important contributions. I don't want to downplay this entire endeavor at all. It's very interesting. It's exciting. There has been a lot of research going after it, what it's actually doing. I'm just saying that there's no intention. Therefore, I don't think there's real meaning. So the meaningless, what you just said about the complexity, I think it qualifies. Given that the complexity is statistically sound. But again, a sentence, just because it's composed of words that follow each other with very high likelihood, is not necessarily syntactically correct. And that's something that Chomsky's colorless green ideas is this famous sentence mocks, that you can use these rules of syntax even with zero meaning and zero statistical structure, is still going to be a syntactically evaluable statement. So the system works in a very different way. LLMs will be and already are excellent tools for particular purposes, just like the wheel was and computers more recently. So they are really good tools. We don't really know how to and what to use them for, and they can be abused just like any other tool. And not just they can be abused, but they are actively abused. But it's not just the LLMs that are actively abused. So I'm not afraid of the AI apocalypse, because I don't think we need to have so complex technology to use it with bad intentions. And everything has been used with bad intentions before. So general AI, even though there's less talk about it now, but there was a lot of lot of hot air around it. It's not that much of a danger, I think. It's the people who use these new tools in a ways that other people are not prepared for. That's danger. That's a danger. Using Facebook with Cambridge Analytica style hacking algorithms, that's a real danger. We know about it for 10 years. We don't know if it's excluded. It's prevented for the next elections. So these are real problems. And in that sense, I don't think that LLMs are a big problem or a big danger or a big threat either. And they are not that miraculous either. They are really exciting new tools that have their really serious constraints and differences compared to human cognition at our current level of knowledge. It can merge in two directions. LLM could be changed to resemble us more, but it could turn out in by future research that our brains are actually a lot more LLM-like than we knew. Yeah.
Yes. I think we'll postpone the value question
Okay.
to the next conversation because I'm getting tired, but it was great. We went
Yes, it was
further,
very
and
nice.
I really liked the moments where it was unpredictable.
Excellent. Thank you very much, and I'm happy to continue.
Thank you, Bálint. Thank you. Bye.
Bye.